So before we jump into the math, remember again, we're opening to page 12. I want to take a quick look at a couple of resources that you have available on Moodle. Just want to make sure you're aware of them. If you don't know how to log into Moodle, see me right after class and I will tell you. But if you log into our class, it will look something like this. There's some class announcements, which you never need to check. I'm not going to put anything there. But the syllabus and the class calendar will be in this folder if you happen to lose your copy. Right here is a link to the playlist of the class videos. You can see it is growing. We've had 2 classes so far and 2 videos right there on YouTube. And then there's a cleaner copy of the calendar, which is this thing, which lives on the back of your syllabus. You can always look at that. But the main thing I wanted to show you right now was this thing right here. It says packets filled in. And it's got this PDF dated from September 5th, which is Friday. So if you open that PDF, it looks like this. And this is what I wrote on the board on September 3rd or whenever our first class was. And so I just wanted you to know that as I write things down up here on the smartboard, you don't need to feel obligated to copy like every single thing that I write. You will always have a full color version of what I put on the smartboard up on Moodle, okay? I can't promise that I'm going to upload this thing every single day, but at least once a week, like after class on Friday, I'll put it up. Maybe more often if I can, but anyway, that's something that's there for you on Moodle. Questions on that? Okay, so let's dive in again here on page 12, and we'll start with the daily summary. And can we begin with Swan? Can you read the daily summary? Thank you. Jennifer, number 1. Okay, so we're going to start with part A. We've got somebody making $7.50 an hour, and we're going to fill in this table that shows the wages in the second column earned for the number of hours worked X in the first column. So, for example, if you work 0 hours, then what are your wages? $0. Unfair, but true. And then if we work 1 hour, how much do we make? $7.50, that's fine. And if we work 2 hours, $15. Okay, so far so good. And then if we work 6, how much is it if we work 6? Yeah, it is 45. What do we have to do to find that the answer is 45? What calculation do we need to do? Yeah, we do the 750 and we multiply that by the 6 hours, right? Easy enough. And so that gives us 45. And then finally, if we work 10 hours, then we make $75. All right, so far so good. Let's go to, yes, Sam. It's up to you. I mean, if there's no decimals there, then we're assuming there's no cents at the end of it. But if you want to be consistent, you could put 0.00. Okay, let's go to Kayla for part B. Okay, let's take a look here. Going from 0 hour to 1 hours, what was the increase? 750. Going from 1 hour to 2 hours, what was the increase? Was 750. And every hour that you work more, you get another 750. It's not something complicated where like once you get past 40 hours, then you're into overtime pay and you get time and a half or something like that. So this hourly rate stays constant, yes? Every extra hour you work, you make exactly the same amount of money. It's another 750 on the pile. So let's go to Julia for each. Yes. Okay, so the fact that every hour we make exactly the same amount more, 750, makes this a linear thing. And it turns out if we graphed, which we will in a moment, we'll see a straight line. Let's move to part C, and we'll come up here to Ashlyn. Okay, so I'm telling you the definition of what it means to see that phrase in terms of. So when I say write an equation for W in terms of X, it means your equation is going to say W equals, and then something with X's in it. That's what my dots represent. I don't know what's going to be over there, but there's going to be some X's in there. So what's the equation here? Well, we better start with W equals. And it's 7.50 times X, right? Isn't that how we found how much money we would have after working X hours? We just multiply the number of hours by 750. We could add some tips on at the end if we wanted to make it. Okay, so there's the equation, and again, highlighting that phrase in terms of, you can see W in terms of means W equals. So as soon as you see that phrase in terms of, it is a very specific mathematical phrase. You are writing that letter, and then equals. W in terms of, W equals. Okay, let's move to part D, where it says graph the equation. So how about we graph the equation by just plotting a few points. For example, go ahead and plot 0, 0, and 1, 750, and then maybe the last one, 1075. So plot those 3 points, 0, 0, 1, 750, and then 1075. And when we plot those 3 points, what do we notice? Sure looks like it's linear. Looks like a straight line will work. So go ahead and connect the dots with a straight line. I don't mean to brag, but I got to say that's a pretty good straight line I just drew there. Awesome. All right, so we've graphed our equation. We'll go ahead and label it W equals 7.50x. There it is. I did. Pretty awesome. All right, part C, where are we going now? Nick? No, not C, E. Okay, let's pause. This is a new definition. You might have seen it in a previous algebra class, but we're defining dependent variable and independent variable. And the one that depends on the other is called the dependent variable. So here's the question. Would you say that the amount of money you make depends on the hours you work? Or would you say the hours you work depends on how much money you make? Typically, it's the money depends on the hours, right? You go out and you work, and as a result, you get some certain amount of money. As opposed to somebody hands you a stack of money, and then you start working until you feel like you've earned that stack, right? That's so I think it makes sense to say that W depends on X. So we call W the dependent variable because it depends on the other. And then we call X the independent variable. Independent meaning free of all constraints. You go out, you work a certain number of hours, there's no restrictions on that, and then you get paid as a result, okay? So we've got dependent and independent. Now I've got this little silly mnemonic device that maybe will help you remember if it's not always clear which one depends on the other. Megan, could you read this if it helps? Okay, so I'm telling you the dependent or dependent one is the one that's by itself, just like Johnny Depp on Islands of the Caribbean. So in this equation, which letter is by itself? Is the W, and so I'm imagining that letter right there is like Johnny Depp by himself on an island, Depp dependent. I don't know if it helps, it's kind of silly, but W is the dependent variable because it's by itself. Moving to number 2, we will come up here to Lydia. Okay, only one of those equations, right, expresses t in terms of x. I want you to copy the one of those two things that expresses t in terms of x. You could circle if you want. Is it the first one or the second one? It's the second one because t is by itself. So t in terms of, as soon as you see that phrase, you know it starts t equals. And so 121x is the right equation here. And then we've got a bunch of blanks. I'll read this one. Since blank is by itself on the island, which letter is by itself? T. In the equation we just wrote, then blank is the blank variable. So t being by itself is like Johnny Depp, dependent variable. The one that's by itself is the dependent variable. And then by process of elimination, the other one is the independent variable. So x is independent. Okay, so we've seen two pieces of vocabulary that with practice I need you to get to the point where you can define things in the right way. So we've got in terms of, and then we've got dependent, independent, right? So just a little bit of practice, get these things straight. And then before we start the activity, there's one last piece that we want to talk about. And we're up to number 3. Let's go to Tara. Okay, let's give this a shot. So intercepts, this is the first time we are seeing that word. To find the intercepts, what we're going to do is individually let one variable equal 0 and find the other variable. So for example, I'm going to start with y equals 0, which just means this thing vanishes, right? Because 2 times nothing is nothing. So the equation I'm left to solve is 3x equals 12. How much is x? It's 4. It's pretty easy. You don't even have to write anything down, right? So x is 4. What did we start with for y? 0. And so that means the point 4 comma 0 is one of our intercepts. In fact, this is called the x-intercept. And then we go the other direction, and we let x equal 0, which means that this 3x part vanishes. And we have the equation 2y equals 12. So y is 6. Also easy. So when y is 6, what was the x value? 0. And so then the point here has coordinates 0, 6. And this right here is the y-intercept. So take a couple of seconds to plot those 2 points and then connect the dots with a straight line. And that's it. That thing right there is the graph of the equation 3x plus 2y equals 12. So 2 things I want to say about this. Number 1, when you find the intercepts, it might be really tempting to say, okay, we got x equals 4, we got y equals 6, so 4 comma 6 is the intercept. And it isn't. It's 2 separate points. And 4 comma 6 is just floating out here in the ether. It has nothing to do with that line. Right? So it's really tempting sometimes to say, oh, I've got the x and I've got the y, so I've got a point. But you really have 2 points. So don't do that. And then the other thing is, some of you, I bet, feel the compulsion to take that equation and solve for what letter? Maybe solve for x, but for me, y equals mx plus b was something that was just like drilled into my head until it hurt. And so I felt like I was obligated to solve every one of these kinds of equations for y so I could get it to look like y equals mx plus b. And you're welcome to do that, but it's a lot of work, and the easiest way to graph this line is what we just did. So don't feel like you always have to get things into y equals mx plus b form. You don't. You can find any 2 points, and in particular, the intercepts are often pretty easy to find. If the mx plus b form business is unfamiliar to you, that's no problem. We will talk about it together soon enough. Any questions on the intercepts? Okay, so then the rest of today, you're going to work through the activities here. If I can help, raise the flag, but check in with your neighbors first, and I'll come around and check homework for those that I didn't check yet.